Here's a video for arithmetic sequences and linear functions. So in this problem it says consider the four explicit formulas, each representing a different arithmetic sequence. We're going to match the explicit formula with its graph, describe the strategies we used. All right, so looking at this first equation here, 2 minus 4 times n minus 1. So I know that my starting point is going to be 2. So looking at my graph, I want to see which term starts at 2. Well, the two terms that start at 2 seem to be graph C and graph B. And then I know that my common difference is negative 4. So since my common difference is negative 4, I know that my function is decreasing. So in that case, between B and C, that's going to be B. So this function is going to be an 2 minus 4 times n minus 1. Okay. Now let's look at the next function. The next function, this one starts at 2. It has a common difference of positive 4. Well, we know the one that starts at 2 is graph C. So it starts at 2 and a common difference is 4. The next term is 6. So it goes from 2 to 6 to 10. So that looks like it seems to be adding 4. So that's going to be graph C. So this is an. Starting point is 2 plus 4 times n minus 1. All right, next one, this one has a starting point of negative 4. So looking at my two remaining graphs, the one that starts in the negative seems to be A. Let's just check our common difference. This one has a common difference of 2. So the first term is negative 4, the second term is negative 2, second term is 0. So it does look like we're adding 2 each time, which would check out with our common difference. So this is an equals negative 4 plus 2 times n minus 1. Which means that graph D should be this last equation, but let's just double check. Starting point of 4, so that works. My common difference is positive 2, so that looks to work as well. So an 4 plus 2 times n minus 1. So in terms of what strategies we're using, we're kind of looking at the starting point and the common difference. All right, so it says let's take a closer look at the relationship between arithmetic sequences and the family of linear functions. We know a lot about each relationship. So here it gives us the explicit formula and the table of values that represent this particular graph. So let's just make sure, we've already established that this equation matches this graph, but let's just make sure this table matches as well. So as we can see that this is my starting point. So at term 1, my term value is 2. So that's this first column or this first row here. And then we can see that our common difference is 4. So to go from 2 to 6, we know we add 4. From 6 to 10, we add 4. From 10 to 14, we add 4. So this shows that my common difference is equal to 4. Just a reminder that the explicit formula for our arithmetic sequences is a1 plus d times n minus 1. So a1 is our first term, d is our common difference. So just as a reminder, what we learned in our previous unit, a linear function equation looks like this, f of x equals mx plus b. In future lessons, we're going to talk more about what each of these letters mean, but that's the form that a linear function is in. And just to define a linear functions have a constant rate of change and form a straight line when graphed. Okay, so now that we're familiar with the explicit formula for an arithmetic sequence, we're going to learn that we can actually convert this to be in the form of a linear function, f of n equals mx plus b, or in this case, mn plus b. So first thing, we're going to replace n with f of n. That's just function notation. And then we're going to rewrite this expression, okay? So we have 2 plus 4 parentheses n minus 1. So first thing we're going to do is distributive property. Distributive property means we're going to distribute the 4 to everything inside of the parentheses using multiplication. Okay, so 4 times n is 4n, and then 4 times negative 1 is negative 4. Okay, next thing we're going to do is commutative property, which means we're just going to reorder the numbers. So basically, I'm just going to move the 2 to be next to the 4. And the reason we're doing that is because 2 and negative 4 are like terms. They're both numbers, so we know that we can combine them. Then my last step is we're going to combine like terms. So like I said, 2 minus 4, or 2 plus negative 4 gives me negative 2. So then we can rewrite this function as 4n minus 2. So this function, an equals 2 plus 4 times n minus 1, can be rewritten in function notation as f of n equals 4n minus 1, which we know is in the form f of x equals mx plus b. So we can clearly see that this arithmetic sequence is a linear function. So it may not look like it when it's in its explicit form, but when we rewrite it, we can clearly see that it is a linear function. All right, so using the examples from the front, for each graph, we're going to write the explicit formula, rewrite the equation in function notation, so f of x equals mx plus b, and then fill out the table with the term numbers and term values, and show the common difference in the table. Okay, so starting with graph A, to remind you, this is the function, the explicit form is going to be an, starts at negative 4, and the common difference was 2. So we did this in the first thing that we did. Okay, now we're going to rewrite our equation using function notation. So we're going to take our explicit formula and we're going to write it as f of n equals negative 4 plus 2 times n minus 1. So looking back at what we just did, we're going to do distributive property first. So we're going to distribute that 2 to everything inside the parentheses. So the negative 4 stays the same. 2 times n is positive 2n. 2 times negative 1 is going to be negative 2. Then we're going to do commutative property. So I'm going to move my numbers together and my variable separate. So it's going to be 2n. I'm going to swap places. So the negative 4 is going to go to the right. So minus 4 and then minus 2. And then we're going to combine like terms. So I can combine negative 4 and negative 2. That gives me negative 6. So it's going to be 2n minus 6. So in function notation, we have 2n minus 6. All right, lastly, we're just going to fill out our table here with the term number and the term value. So term 1, our term number is negative 4. Term 2, it was negative 2. Term 3, it was 0. Then 2, then 4. To show our common difference, to go from negative 4 to negative 2, we add 2. From negative 2 to 0, we add 2, and add 2. So that means our common difference would be 2. All right, now this is graph B. So to remind you, our explicit formula was at an. Our starting point was at 2, and our common difference was negative. It was minus 4 times n minus 1. So now we're going to rewrite it in function notation. So f of n, 2 minus 4 times n minus 1. So first we're going to do distributive property. So we're distributing a negative 4. So 2 stays the same. Negative 4 times n is negative 4n. And then negative 4 times negative 1 is positive 4. Then we're going to rewrite this. So we're going to group together our numbers. So basically we're just going to swap places for the first two numbers. So it's going to be negative 4n plus 2 plus 4. And here we can combine our numbers. So our function in linear function form is going to be negative 4n plus 6. All right, now using our table of values. So term 1, we started at 2. Term 2, we went down to negative 2. Then we have, here we can see, then we have negative 6. And then we have negative 10. And then lastly, we have negative 14. So to show my common difference, to go from 2 to negative 2, we subtract 4, subtract 4, subtract 4, subtract 4. So there's our common difference. So D equals negative 4.